page 82 then, question 4. First part of question 4 says derive the base units for work done. Well, 4a, work done is force times distance, so the base units of work done are the base units of force times the base units of distance. We know that's meters, that's quite easy. The base units of force, not quite so obvious. Let's go to a second equation then for that one. Force is mass times acceleration. The base units of mass is kilograms. The base units of acceleration is meters seconds minus 2. So we put those two together, we get the base units for force is kg ms minus 2. So we now know the base units of force. Substitute that back into here, and we get the base units of work done is the base units of force kg ms minus 2 times by meters, the base units of distance, which is kg m squared s minus 2. That's our answer. Part B, for part B, then says calculate the kinetic energy of the person on the moving escalator. Kinetic energy is half mv squared. We know the mass. We don't know the speed of the person, but we know that v is distance over time, or displacement over time, and we know they move 12 meters in 8 seconds, so that comes out as 1.5 meters per second. So we can calculate the velocity from the data we're given in the question, 1.5 meters per second, and then we say kinetic energy is half times mass times velocity squared, is half times the mass of the person is 70 times by 1.5 squared, and we get an answer of 79 joules, if you work it out. Okay. Part C says, next part says, calculate the gravitational potential energy gained by the person. So let's have a look at that. Part 2. So part 2 is gravitational potential energy gained by the person. GPE is mgh. We know the mass of the person. We know gravity. We don't know h though. Here's the diagram of the situation, like this. We know this is 12 meters up here, and we know it's 32 degrees there, and that's h. We're not given h, but we know 12 meters and 32 degrees there. So of course we can say from trigonometry h equals 12 sine 32 degrees. Why is it sine 32? Because of SOHCAHTOA. Sine goes with opposite, cosine goes with adjacent. So hypotenuse times sine 32 gives us that 12 sine 32, which is 6.4 or 6.36 meters. So we know the height there. Now it's easy to work out GPE, which is just mass times gravity times height. So it's just going to be 70 times 9.81 times this figure here, 6.36, which gives us a value of 4367 joules. Okay, so that's our gravitational potential energy increase. Part 3. Then calculate the power required to lift the person from the bottom to the top of the escalator. How to do that? Well, power is work done divided by time. We know the work done is what we just had there, 4367 joules. So we know that. We know the time is 8 seconds. That's what it takes to go to the top. So therefore, power is straightforward. 4367 divided by 8, which comes out as 546. And of course the answer is in watts because it's a power.